In this problem, they tell us that the rate of change of the number of coyotes, which is represented by n of t, the rate of change of that would be the derivative of n with respect to t. So I have dn dt, and a population means equal, directly proportional to, so I'm going to introduce a constant of proportionality, 650 minus n of t. 650 minus n. So here is our differential equation. The first thing we're going to do is we're going to get started and we're going to separate variables. So I'm dividing both sides of the equation by 650 divided by n, so that all of my n terms are on the left side of the equation, and I'm multiplying both sides of the equation by dt. Now I'm going to integrate both sides. On the right-hand side, when we integrate 650 minus n, we will have negative natural log, absolute value of 650 minus n. It may be helpful to go through a u sub to see where this negative is coming from. So go through this integration using that as your u and check your du and so on and so forth. On the right side of the equation, integrating k with respect to t, we get kt plus our constant of integration c. I want to solve for n, so I'm first going to get rid of the minus sign that's in front of this natural log by multiplying everything in the equation by negative 1. So all of my signs in the equation have changed. Now I'm going to exponentiate both sides so that I can cancel out the natural log. So using e on the left side of the equation will cancel out the natural log and just give me 650 minus n. Using e on the right side of the equation will give me some constant multiplied by e to the negative kt. Then I'm going to go ahead and solve for n. So I would subtract 650 from both sides and multiply both sides by negative 1 to get that n is equal to 650 minus ce to the negative kt. So here we have our general solution. Now that we have our general solution, we're going to go and use some of the conditions that they gave us. For instance, that when t is equal to 0, the population is 300, to start solving for some of these unknowns. So we know that if we were to plug 0 into this function, that our answer would be 300. So when we replace t with 0, we get out 300. Anything to the 0 power is 1, so we'll be able to solve for c. So we now have 650 minus c is equal to 300, which implies that c is equal to 350. So now we know that the equation is n of t is 650 minus 350 e to the negative kt. We still haven't solved for k, which we will need, because ultimately we want to know what is the population when t is 3. So what we want is what do we get out when we plug 3 into this function. But to do that, I'm going to have to know what k is first. So to find k, I'm going to use the condition that when t is 2, the population is 500. So now I know if I plug 2 in for t, that all of this should be equal to 500. So now we can use this equation to solve for k. So I'm first going to isolate that exponential. I'm going to subtract the 650 from both sides. Then I'm going to divide both sides of this equation by 350 and simplify that fraction. 150 divided by 350 simplifies to 3/7. Then I'll use natural log on both sides, and I will divide both sides by negative 2. So natural log of 3/7 divided by negative 2 gives me approximately 0.4236 for my k value. So now I know that the entire model for the function, I'm taking the general solution and I'm combining what we found for c and k and putting them together to get that our function is 650 minus 350 e to the negative 0.4236 t. Now that we have the entire model, we are able to approximate n of 3, what we get when we plug 3 into this function. So we have 650 minus 350 e to the negative 0.4236 multiplied by 3, and this comes out to give us approximately 552 coyotes.